very lucky to have today. Mina is going to be presenting her paper on writing in AI. She is currently a postdoctoral researcher at Microsoft New York City, and Microsoft Research in New York. Did her PhD at Stanford, and she's going to be joining the University of Chicago in the computer science department. Very glad to have you here. Thank you.
Awesome, thank you. Let me check if this thing works. Okay. All right. Hi everyone. Today we are going to talk about writing with language models. And as you can see in the demo, oh, by the way, should we unmute or is it unmuted? Can people on Zoom hear us?
Oh yeah, Zoom folks.
Okay, I see we. Cool. Okay, so yeah, feel free to stop me and ask questions or share your thoughts at any moment. For those who don't know me, I am currently a postdoc in Microsoft Research in New York City in the computational social science group, working with Jake, Dan, and David. And before that, I was at Stanford, and my main training is in natural language processing. And recently, I've done some work in human-computer interaction. And maybe what's unique about doing PhD at this time is that it really coincided with all the generations of GPT, which was fun. And GPT-4 literally came out during my job talk. And today we will mostly talk about the recent models. But if you're curious about the work prior to that, please feel free to ask and reach out. All right, so one question. Raise your hand if you've used ChatGPT. Everyone? Okay, raise your hand if you've used ChatGPT for writing. Okay, most people. Cool. So yeah, I think chatbot interfaces have grown significantly in popularity. So you can think about ChatGPT or Bing Chat. And although these tools are pretty general purpose, a lot of people are using it for various tasks, including writing. And there are more writing specific tools, such as Grammarly and WordTune, that can underline parts of your text and suggest changes, or it can give you dozens of different ways to paraphrase your sentences. And if you're into writing, there are actually way more niche tools built specifically for them. So here I'm showing one example called pseudo-write. So in your story or text, you can click a word, and then it will show you multiple word clouds, and then you can click another word in the cloud, and it will show you more related synonyms or words, and then you can expand your vocabulary like that. So that's another way that people can interact with language model. And this is a research prototype called Pale Brush. So here the interaction is that you draw a line sketch to represent the protagonist fortune. So it goes up and down, and you have challenges and overcome. And then based on that, the language model generates the story to follow that curve. So yeah, there are many different ways that one can interact with language models beyond the chatbot. And of course, there are also many different domains that you can use these language models to support your writing. So just to name a few, marketing, law, creative writing, medicine, and communication. And writing with language models have and will have a huge societal and economic impact. And a lot of you, or some of you, have already measured and are looking into that. And here are rather more anecdotal cases. So this one says that AI content generation tool powered by a language model was valued at $1.5 billion. And an essay co-written with a language model won the best American essays. And then of course, ChatGPT amassed a significant number of users in such a short amount of time. And a lot of us are still using it. And then it shows that there are 1 billion plus visits per month. Okay, so as NLP and HCI researcher, I am trying to explore the space of writing with language models with these three questions today. So first one is, how can we capture interaction between human users and language models? And second, how should we choose which model to use? And third, what do we need to consider when designing writing assistants? So let's dive in to the first question. So this part of the talk is based on the paper titled Co-author, Designing a Human AI Collaborative Writing Dataset for Exploring Language Model Capabilities. This work was published at CHI 2 years ago. All right, so here is a traditional NLP way to think about story writing. So given an input, and let's assume that there is a story title, like the mage, the warrior, and the priest. You feed that into the model, and then you generate a story. Okay, so the model generates the entire story, and then we have, like automatic metrics to measure some qualities about like this output. However, that's not really how we and like a lot of people use these models in real life. It looks more like this, where the user is like interacting with the model. So again, in this simple example, let's assume that maybe the user has some idea of like how to start off the story. So user writes once upon a time, and then maybe queries the system for some inspirations, and the system might give not just one, but multiple suggestions. And then the user goes through them and then accepts one that she likes. But then maybe the user doesn't like some part of it, and then go back and edit, and then maybe ask for more suggestions, and then accepts one, and repeat the process to write a story. So in this case, the output of this entire process is not just the model written text, but it's a combination of user written and the model written text. But the more important point here is that this interaction traces, which is basically a sequence of all the events that happen during this interaction, have so much like richer information. For instance, like the query event can tell us about, okay, when does the user need support or inspirations from AI? Or accept event can tell us something about the user's preference. And maybe the edit event can tell us about the room for improvement in the model's outputs. So with those interaction traces, we're going to ask, like, was the model helpful to users, which was a bit difficult to do with just the model outputs. But then helpful is such a broad and vague term that's hard to define. So we're going to look at it in 3 different ways. So first, we're going to reason about language models' language capability in this interactive setting. Can language models generate fluent text in response to the user text that changes like dynamically throughout the interaction process? And second, we are going to look at ideation capabilities of these language models and ask, can language models contribute new ideas to users' stories? And third, we are going to think about the collaboration between human and AI and ask, among all these like different things that can vary in this collaboration process, like what influences the patterns the most? So to investigate those questions, we built this tool called Co-author. So it's basically a very simple text editor with one additional functionality. So whenever the user clicks or presses the tab key, it shows like 5 different suggestions, and the user can navigate using arrow key. They can just dismiss it all, or they can accept and then maybe change their text around. So it's pretty simple interface. And with that interface, we collected nearly 1,500 like writing sessions between 63 users and an instance of GPT-3. And all of this data are available and replayable on the website. So if you're interested, please feel free to check it out. And we studied this in 2 writing tasks, like one was creative writing and one was argumentative writing. But for the interest of time, I'll focus on the creative writing results. Okay, so the first part was about language capability. So can language models generate fluent text in response to user text? And here on the x-axis, we're looking at all the sentences that are written by only human, or only language model, or both. It could be written by the user first, and then completed by the model, or it could be fully written by the model, but maybe the user edited some parts of it. So those are counted as both. And when we look at the number of errors, like mostly spelling and grammar errors, we see that the sentences written by both human and AI have the fewest errors. And I think that matches with John's paper about the algorithmic writing assistance. So we do see some improvement there. And for vocabulary diversity, the difference is smaller, but at least like directionally, I think it's promising in that like the sentences that are written by both human and AI seem to have slightly more diverse vocabulary. And again, this is like very grounded in the setting that we had. So here the users got the suggestions for each sentence, but there are papers that showing that actually this can be the opposite. You might see more like homogeneous written artifacts, especially when the AI is generating a big chunk of text and then the user is editing some parts of it as opposed to interacting at the sentence level. Okay, second thing is about ideation capability. So idea is something that's like really hard to define. So here, like our approach was to take a conservative measure to identify like idea and then show at least some evidence that yes, these models are contributing to the ideation process and they seem to be useful. So the way we went about it is we identified new named entities. So those are things like people or locations in the model suggestions. So if the model suggests, say, new character, Dr. John, that didn't appear in the previous part of the story, then we consider that as an idea that was proposed by the model. And then if that character or new location gets reused in the later subsequent part of the story, then maybe it's safe to say that, okay, maybe those ideas were useful in some sense. So with that, we see that 13% of suggestions contained such new named entities. And among those, 20% of them got reused. But if you have any other ideas for how to like define and identify ideas or like some kind of contributions for creativity, please let us know. Lastly, we looked at some collaboration patterns. You don't have to look at all the text, but we basically looked at like how the diversity of suggestions might affect the way people use and like interact with these suggestions, like when the suggestions are more similar to each other versus like more diverse. And then we also varied the prompts that people start their stories with. So it can basically represent like different topics that the model is generating suggestions for. So prompt is on the x-axis on this plot. And then obviously there were like many different users. And the TLDR was that basically the user preference like really dominated the collaboration patterns that we saw in this experiment setting. So like user one, so these are like top 10 users who wrote like the most stories. User one, regardless of diversity of suggestions and regardless of the prompts, they like using suggestions. Whereas user two, they write their text like much more than the user number one. So yeah, we do see that like user preferences was kind of like dominant in this data set. Okay, and there are still like so many open questions that we can explore. And I think co-author can be a good starting point to investigate these things. So one question we had was about like changes in writers' behaviors and writing outcomes. Because it was collected, I think, 2021 or yeah, I think, so people are pretty new to this thing. So maybe we can actually like see the novelty effects and like how people use this autocomplete system like differently and like how that might have weared off as they interact more. Because again, like we had 63 users writing like thousands of stories and essays. And so yeah, it'd be cool to see any like longitudinal changes in each author's or each writer's writing sessions over time. And yeah, I also mentioned like homogenization effect. And it'll be also interesting to see like linguistic accommodation. So when we are talking, like I might be subconsciously mimicking the way you talk or like your body language or maybe your accent somehow. And like I'm curious whether that also happens between humans and AI. Like how does the style or voice or tone of a writer or a language model influence that of the other over time? Like we did have some participants who were saying that like they really tried hard to resist like what the model was suggesting, which were like very violent and like undesirable, but then yeah, it was very hard to steer the model's behavior around so that like if that persists, like does it actually affect and you end up writing something like really violent, and how can we mitigate that? So yeah, there are so many questions. Happy to talk more about them, but yeah, please consider using co-author. So yeah, the first part was about co-author, which is a tool and also data set that captures and replaces human language model collaborative writing. And we demonstrated the usefulness of the interaction traces as a data set to think about language models capabilities in like collaborative writing setting more generally, and all the data and interface are publicly available. Cool, I'll pause here for a bit and see if there are any questions. Drink water. Yes.
How did you take into account volume, number of words, number of pages, length of story? Because it looked at in the outset they were all relatively short stories.
Yeah, these were very short stories. So we basically asked people to write a story for 10 minutes, and it resulted in like on average 400 words. So like as the story gets longer, and if you know like they're professional writers who invest more time in like planning and like all the plots and like you know like word building, the dynamics would probably like totally change. But yeah, this was like a very short session. Yeah. Yes.
How did you, in the last slide, are those things you did or things that you're saying are next steps?
Next steps. Are you interested?
Yes. I was wondering if by homogenization you were thinking of the, like homogenization in terms of the semantics or of the actual content, the ideas, that sort of thing, or about the language mostly?
Both. So yeah, there are some papers that came out like this year and last year that looks at, I guess, yeah, both like semantically and also just like based on n-grams and stuff like that. For the semantics, people usually use like sentence embeddings. I think that is a good proxy, but I think it's still like very far from like how do we even, like go about idea, for example, and it might be that like people don't necessarily directly use like what AI generated, but still can get inspired by it to do something. So yeah, I think we are seeing some preliminary works in the space, but yeah, there's like still so much to explore. Yes.
If I get a bunch of recommendations while writing and you see that I ignored all of them, it may look like pessimistic data, like, oh man, you know, the co-author didn't help us so much. But if I keep opening it up, that may also, is that like also revealed preference that I'm getting inspiration from it, even if I'm not using it directly?
Yeah, for sure. So in this work, we didn't really say it's bad if like people don't use suggestions. We were like, so the goal of this work was like really just to systematically capture everything, because at that point we were still trying to understand what do people do with this thing. And I think it's like totally true that some people are, you know, like more selective and maybe they want more agency. So then the way that they want to integrate the AI support is like by inspiration as opposed to like directly using whatever it generated. So yeah, I think probably we can see those variations in the data set, but I haven't like checked. But yeah, that's a great point. Yes.
How do you capture like annoyance? Or, you know, I'm trying to think of like one of those, like I have the Grammarly Go AI that pops up whenever I write in Word, and that's kind of cool. But it also pops up when I'm doing a lot of things that I really, and it's like it'll block the enter button, and I get really annoyed at it, and I like start rage turning it off sometimes. You know, are you going to be able to see? So I can imagine there could be some situation where early on you know, when it's like it's a blank page and they really need ideas, maybe it's very useful, and then at some point they're like, why is this text always, there's like 5 lines of text popping up and the colors are changing and I can't look at what I'm writing, and they can, you know, is that, do you see them like turn it off at some, or can you see if they just turn it off as opposed to stop accepting suggestions, or
Yes.
would you just capture them?
Yeah, great point. I think we will probably talk about that in the third part of the talk. It's not really about annoyance, it's I guess more about, okay, what kind of things do we need to consider when designing a writing assistant? And yes, I think we generally want to account for what kind of writing stage that the user is in and when they want to receive the suggestions. So yeah, we'll talk more about those design choices in the third part. Okay, cool. Second part is about how should we choose which model to use. And this part of the talk is based on the paper titled Evaluating Human Language Model Interaction. So this part goes beyond just the writing tasks, although it does look at 2 writing tasks, but you can think more broadly about like language-based human AI interaction and how we can like frame our thoughts when we're designing evaluation metrics to think about the interaction. Oh, and this was a big collaboration with people at Stanford, so all the kudos goes to them. To recap, most language models are developed and evaluated non-interactively. So in the story writing setting, it was like you feed the input in, you get the output, you analyze the output. But now we're going to talk about question answering task. But before doing that, pop quiz. Before Nixon resigned, how many believed he should be removed from office?
79%.
Who thinks it's A? B?
Who doesn't know who Nixon is?
C? D? Cool. Okay, we have good spread. So in the non-interactive setting, where we usually evaluate language models on a static benchmark in isolation, what we would do is to take this question and multiple answers, feed it into the input, pretty much verbatim, and then the model spits out answer, D.
Yes.
And if you know, like has the superhuman performance and gets the answer. So the answer is D. But in reality, like we don't know the answers, and that's not like how we usually use these models. Like imagine these models like as being chat, like where you're using it as a search engine. So let's imagine what might happen, like if you're trying to answer that question, maybe as part of homework, or maybe you're answering the question to your kids. So for the input, let's say that you just like copy and paste the question, and then feed that into the model. Then what happens is that the model, actually like the same model, generates a majority of Americans. And that's not really helpful to choose the right answer in this case. So then what happens? Do we just give up?
The user asks, like, what's the exact percentage?
Exactly, yeah. So we would like revise our query and maybe make it more specific. Like what percentage of people believe Nixon should have been removed from office? Then the model, again, the same model says like approximately 60%. And again, that doesn't match with any of the multiple choices in the original question. And so like in the traditional NLP benchmarking setting, it'll be considered as wrong. But in this case, it actually helps the user guess the right answer. So how can we like account for all these things that like could happen in the interactive setting? And the problem right now is that language models are chosen based on their non-interactive performance. Like whenever a new model comes out, it shows like all these numbers and leaderboards and stuff like that, and we pick the model with the highest numbers. But then like if we explicitly or implicitly optimize for non-interactive performance, will that improve interactive performance or the user's experience while interacting with these models? So that was the key question that we wanted to answer. And to do that, we proposed an evaluation framework called HALE, so Human AI Language-Based Interaction Evaluation. And you can see that in a traditional benchmarks, static benchmarks, what we focus on is like that red cell. So that one represents basically that one looks at the model outputs for evaluation targets. So it only like uses the model outputs, and it reflects the third party's perspectives. So it's usually like researchers who say that these metrics are the ones that matter, or like other human raters that you might recruit. And we usually focus on quality for evaluation criteria. But in interactive setting, we argue that it is important to consider all these different aspects. So for the evaluation target, as we saw in co-author case, the process can tell you like so much about like, what's going on between the user and the model. So we want to account for the process. So that might look like looking at helpfulness of intermediate suggestions as opposed to the very last model output. And for the perspectives, now there are users who are directly interacting with these systems. So we can ask the users like, okay, like, how did you feel about it? How much effort like did you have to put in? And for evaluation criteria, we also want to account for preference, things like enjoyment or satisfaction. Even though like one model output has like great quality, let's say that it generated a story, I may like it, but you may not like it. And it matters that you like it, like if we're designing a system for you or like there's a specific user group. So we want to account for that. With that framework, we designed 5 tasks to capture a variety of interactions beyond writing. So we have text summarization and metaphor generation for writing tasks, but we also have social dialogue, question answering, crossword puzzles to have some variety of the interactions that we're studying in this work. And of course, shout out for like the work that looks at it in the mathematics setting and also like the program setting. So yeah. And this is an example of interaction for interactive question answering, which is the running example that we've seen. So the user comes in, types query, presses the button, system output shows up, and then the user can like keep querying if needed, or like if it's good, then they will choose the answer and then go to the next question. And there is a more detailed blog post written by Mega and John, which is really great looking into the interactive question answering and crossword puzzle in more detail. So if you're curious, please check it out. Okay, so with that cube thing and 5 tasks, we collected over 1,000 interaction sessions across 5 tasks, and we designed 47 evaluation metrics covering all these dimensions like 2x2x2 cube. And we compared 4 models. You don't have to know details about these models. I'm going to mainly compare language model 1 and 2, and the main difference between these 2 models is the size. So the language model 1 is like 100 times bigger, and usually the bigger, the better performance. All right, so I'm going to share 4 findings with 4 questions. So the first one is, do we really need to evaluate in interactive settings? It's expensive, it's, like, it takes time. And the answer is yes. And of course, like a lot of times, like the performance in the non-interactive setting translates to the interactive settings. But then there are like notable exceptions. So I'm sharing like these notable exceptions that are specific to some task, like some domain. But if you're designing a system for that task and the domain or like similar kinds, it might matter because, again, language model 1 is like 100 times bigger. What that means is that it's usually much more expensive, it's much more slower, and have much more environmental impact. So we see that although the language model 1 performs way better than language model 2 in non-interactive setting, they actually perform similarly when human users are interacting with them. So if you're designing a system for that setting, like it might be, like useful to consider using a smaller model that might be just like as good as the language model one. But actually, one interesting thing about these plots is that like if you have good eyes, yes.
Quick clarification, so interactive setting here similar or different from chain of thought prompting? Like how is prompt engineering different from an interactive session?
Right, so prompt engineering, so if you're just thinking about like writing a prompt and feeding that into the model and the model generates something, that's basically like one turn. Whereas here, what we consider as like interactive or interaction is like multiple turns. So it might be something like maybe like chat history where there are like many different turns, or it can be that you iteratively revise your prompts, which is like what's happening in the interactive question answering, and then query the model, and then based on the model output, you like revise your query. So it's not like completely independent. So if you're just doing like one prompt, like model output, and then you're in completely different setting, you write a prompt and then like get a model output, we don't really consider that as like interaction in this way.
So like if you could optimize your prompt right away, or you could take like several interactions, and it's the latter that you're sort of more interested in, right? Like you want the sort of iteration process.
Yeah, exactly. We want to see like how the user prompt affects the model generation, and also that like informs the user prompt, and then yeah, like that feedback. Yes.
Do you have a sense of how well the human does with no language model?
Good question. Trying to think. I think we do have that data. I'm gonna guess much worse, but yeah, I can't remember off the top of my head. I think we had like half of the questions answered without language model and half of the questions with language model. But yeah, I guess I only have the results for the like with language model.
Because one other question is like, it's kind of interesting that the humans with model 1 do worse than the model alone. Like, can you speculate why that might be the case?
Exactly, that's what's coming next.
Oh,
Yes.
okay.
And I saw another hand.
Yeah, I was just wondering whether the human was actually able to just copy paste the whole question and answers into the model.
Yes, they were able to copy and paste if they wanted.
So they didn't have to do like the kind of transferable exercise to like read the text directly and then find the right answer.
So the interface was like you have the question and multiple choice answers like on the right side, and then if you want, you could like drag so that you can copy and paste and form your query. But it all depends. I guess
You
yeah.
see this, right, in your outcomes to see whether the person would just type one question or whether the person would just like copy everything and then.
We do see a lot of variation. Yeah, some people would just type keywords. Some people would copy and paste the question. Some people will actually formulate it so that the model will complete the sentence. Because again, like some of these models are not like instruction tuned. I guess I didn't mention that. But yeah, some of these models are not instruction tuned. And what that means is that their natural way of generating is like predicting the next word. So for some models, it actually works better if you frame it as like open door notes mean or are, and then the model will generate something. So that's like one way to get the information out of this model, and maybe that strategy will work better for some models, but not for the others. And in the paper, we do see, so we analyze like the question types or the query types that people use, and then it really changes like based on which model that they were interacting with. They're kind of like finding a better strategy over time because they were answering, I think, 11 questions in a row.
But they could also include the answers, right?
Yes. Yes. Some people figure it out, like, oh, okay, it works better if I include these multiple choice answers. Some people may not just like continue to ask, just like how we would query Google. Okay.
Okay, thank you.
Yeah.
I'm just curious, like the slide before, do you really measure the actual time people spend to interact with language model to achieve that level of accuracy?
Yes.
And then do you have the like trend of their like effort being decreased over like collaborating with language model?
Right. Great question. I think we that's one way to define effort. And I think we didn't do that because we instead used the number of queries people made, and that pretty much like correlate with the time that they spent. So yeah, I think we overall do see the number of queries people made like differing across the models, and then I think over time it's in a like decreasing trend.
Thanks. So, LM1 was released after LM2, right?
Yes.
Maybe it could be that.
Wait. I think they were released at the same time. Where are they? Yeah, they were released at the same time.
Okay. Maybe my question is in general, if the non-iterative performance criteria is the standard, each maybe language model try to maximize that performance criteria. So it's in the end the performativity of the criteria that we are looking at that makes one model more stronger than other. It's not whether it's like a large or a small data they have, because like I think if you release a new model, you want to maximize the performance measures that is standard. But if we change to this iterative measure that you suggested, maybe we will not see this kind of correlation between whether we need all the big data or not.
Yeah, so yes, I guess that's true. And here the assumption is that these models are pretty much like general purpose. So they're evaluated on like hundreds of different tasks. And like a lot of people, I guess, don't really have, at least like back then, didn't have access to like fine-tune these models. And so like assuming that kind of, like scenario where you can only access these models through API, and then you're trying to find a model to build your system for like your bespoke system for specific users and tasks, I guess these considerations become more important. But yes, it is true that there is definitely some misalignment of like what happened when we were building these models and how they were evaluated and like how we're evaluating in the interactive setting. Good point. Okay. I'll try to breeze through the results. Okay, so you asked why did the accuracy drop? And one reason might be the variation in user queries. And these models are brittle. So let's say that in the same question, with the same question, the user might might have a hunch of like what the answer is. So then the user might use this system to verify their understanding or their knowledge and ask something like, did 50% of people believe Nixon should have been removed from the office? But then, again, the very same model would contradict itself and say, no, that's not true, it's actually 29%. And so that might lead the user to choose the wrong answer. So this is like one specific example, but in general, there's a huge variations in terms of like how people formulate their queries. And we've seen many evidences that these models are not robust to this kind of like distribution shift. So they may perform really well when the question and the answers were given, but then like with some variations, the performance like could fluctuate. So that's why we think it's important to evaluate these models in the interactive setting. Okay, secondly, why do we need to care about output versus process? And that's exactly what Shannon asked. There are many different ways to approximate human effort that goes into doing a task with the assistance of AI. And you can define it based on the model output or like the final output of the interaction, but you can also define it based on the process. And we see that if you define it based on the process, it's kind of blocked, but it says user survey responses. It better matches with what we can see from the user surveys, user responses. Okay, sorry that I'm kind of rushing. I guess we don't need to cover everything. But yeah, these results are all in the paper, so I'll just like highlight the main points. And why do we need to care about preference as opposed to quality or in addition to quality? So we usually have like a set of metrics that we care about, and here the example is social dialogue. And there are, tens of metrics that a lot of people use, like fluency or sensibleness or humanness and like dot, 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 dot. And then there's also specificity, like how specific are the model utterances with respect to like what you've said before. And what we see is that users may care more about certain aspects of language models than others. So if you just take all these metrics and get the average, like language model 1 outperforms language model 3 on basically all the metrics except for specificity. But then like when you ask the models, like how inclined are you to interact with this model more like in the future, then we actually see that it's pretty similar. So then like we hypothesize that maybe like the user preference is like more aligned with the specificity as opposed to like these other many different quality metrics that you might care about. Again, it's like very specific to the task and the setting, but I think it highlights the fact that we want to consider like what the users of your system prefer. Last thing, third party versus first person. So one interesting and maybe counterintuitive thing that we saw was that, like usually you care about users, okay, you care about users' preferences. So then maybe you will just have users try these different models out and take user ratings as the main way to evaluate these systems. But that also have risk, because we do see that like users may perceive language models to be more helpful than they actually are. So in this example, users perceive language model 1 to be way more helpful than language model 2. But then when you actually look at their performance on this task, like crossword puzzles, users with language model 2 performed a lot better. And there can be many different reasons for this, but one is that language model 1 is like much more confident and much more fluent. So when they're asserting certain information to be true, I think it's easier for users to be fooled and believe that, oh, okay, that is true. Okay, so that was the second part of the talk where we proposed a new evaluation framework called Haley. And then I shared 4 notable cases where non-interactive and interactive metrics diverge along the 3 dimensions. And just like co-author, all the data and the interfaces are publicly available. Okay, so I was told to finish 5 minutes before 1, so we have 9 minutes. Okay, so the third part of the talk is about like what do we need to consider when designing writing assistants. And this was an even bigger collaboration, community collaboration with 36 researchers across 27 institutions. And Shannon was one of them. So this paper is titled A Design Space for Intelligent and Interactive Writing Assistants, which will be presented at CHI. So motivation for this is that there are a lot of writing assistants. There are ChatGPT, Bing Chat, Grammarly, WordTune, and Sudowrite, and ProWriting Aid, and Copy.ai, CopySmith, Jasper, and so many more. But then there are even more proposed writing assistant like prototypes in the research community. So HCI community like designs new user experiences and user interfaces. NLP community develops new models like new architecture, data sets, and benchmarks. And then there are also like communication community looking into how that affects the way we communicate and perceive these like written artifacts, and how the written artifacts change or how the writers change. And then maybe more familiar with this crowd, like how does that more broadly like affect the society and labor market, economy, and so on. So I personally find it really difficult to keep track of all these new things and contextualize each paper and each like writing assistant and compare them and like try to generalize the findings. So this project really started from this challenges that we are facing right now. And our approach was to create a design space for writing assistants. And design space is a very well established concept, which is basically a taxonomy that presents critical aspects of a design. So it can help you communicate with like other researchers and other stakeholders. It can also help you envision like alternative designs that you can use, or it can also help you like identify gap in the current literature and think about like new innovations. And we have operational definitions for intelligent and interactive writing assistants, but I think it's pretty straightforward. So that is our scope. And then we decided on the 5 aspects of writing assistants. And the first 3 are user, technology, and interaction. So the user interacts with technology through the interface. And then there is a task that affects like part of the user and interaction and technology. And then there's the ecosystem that all of this like exist and influence each other like within. So what do we do with that? We did a systematic literature review by first sampling papers that have write in their titles from NLP and HCI venues, and then filter these papers based on the scope that we had. And then we broke into 5 teams. So each team was basically like an individual research group, which had like team lead, team members, and advisors. And then what they did was to take this set of papers, identify the ones that are specifically relevant to, say, task aspect or user aspect, and then they tried to identify all the key components that matter for that aspect. And each paper was read by at least 2 members, and then you iteratively like code those papers, and then you meet, and then you maybe create new codes, or you delete some codes, or you merge some codes, and then you repeat that until you read all the papers and annotate all of them. And what do I mean by dimensions and codes? Let's take a look at the user aspect. So for user, we are calling it aspect. And we have dimensions that are like fundamental components of the aspect. So it can be things like demographic profile, user capabilities, relationship to system output preferences. And then the codes are basically the options for all these dimensions. So after we did that from each team, we gathered to create a design space. And then we coded the papers with this final design space. And we have like reasonable intercoder reliability. Okay, so that is our final artifact and main contribution of this work. And obviously I cannot go over each and every dimension and code in this talk, and I have only 3 minutes left. But yeah, there are so many more details in the paper. So we like define each dimension and code, and then like list the examples to help you like navigate and think about these different elements. And I guess I will just maybe go over this one aspect during this talk, so interaction aspect. So here, I want to make a point that the chatbot interface is, although it's the main paradigm that we're are interacting with language models these days, it's really just like one code for one dimension in one aspect. There are like so many things that you can vary when designing writing assistants, and like when you want to avoid annoying users, like there are so many things that you could consider from the user aspect side, but also things that you can like change and tune in terms of like how you design the interface. So there's like for example, you could potentially like differentiate how AI generated text looks from how user written text looks. And you could also change like who initiates the system suggestions. Is it like from the user or is it from the system? And how do users integrate the system outputs? So these are some of the considerations that we identified by doing the systematic literature search. And we actually have so much to show you, but we're out of time. User aspect. So I think it's worth spending last 1 minute highlighting this point, which is that all these dimensions and codes are interconnected. So if you care about, for example, maintaining users' ownership over the written text, maybe you want to keep the users accountable for what they write and make sure that they feel responsibility of like what they've written, then maybe you can consider, again, like from earlier question, having user not just like directly integrating system output, but having them like do some work, like maybe like have something that will inspire the users, write something, but maybe not directly inserting into the text editor. Or you could also visually differentiate, maybe with different format, so that it's easier for users to check which parts are actually written by AI, and maybe if they want to verify or like edit it so that it's more of user written, they can do that, or you can put it in a different location so that there's more work needed to integrate the output. So yeah, like based on this kind of interconnection, you could form a hypothesis, and like here's an example, like users feel more ownership and responsibility when they have to put more effort in integrating system outputs. So I think there's a lot of fun things that one can explore by connecting these dots and thinking about, okay, like what are the dimensions that can affect like the interaction, or like vice versa. So the next one was the other one, and we are out of time. So cool. That was a very quick summary of our most recent work. But I hope I piqued your interest, and if you are, working with writing assistants, or if you're using writing assistants, or maybe you're searching for a writing assistant that would, satisfy your needs, consider checking out our website. We released the annotated papers in this like super cool website Shannon built that you can click around the dimensions and codes to filter out the papers that are relevant to certain codes. And we believe that the design space can help you identify relevant dimensions and consider alternatives when designing a writing assistant, and recognize interconnection and form hypotheses, and also identify understudied areas and envision new designs and contextualize existing findings. That being said, it's neither exhaustive nor permanent. Things will evolve over time as we see more, newer models and new ways to interact with these models. So we invite all of you to join the discourse and contribute. And if you have built writing assistant, please consider adding that to our corpus. And yeah, these are also all publicly released. Cool, that was it. Thank you so much.
Thank you, Mina, very much. Appreciate that. Just for everybody's information, 2 weeks from today is our next IDE Lunch seminar, Tanya Babina of Columbia University. So we'll see you in a couple of weeks. And thanks again, Mina.
Yeah, thank you for all the wonderful questions, and thanks for having me.
Thank you.